Good afternoon, everyone. I'm Enrique Dominguez, Fabrication Team Lead here at SIE, and this is Ian Lilligren, Production Supervisor at SIE. Today we'll explore our workflow for designing and engineering mechanical museum interactives. Tactile and mechanical interactives play a crucial role in museums. They make exhibits more engaging, aesthetically appealing, and accessible to a broader range of visitors. These interactive elements enhance the visitor's understanding and provide a unique hands-on learning experience.
All right, so one of the first steps that we take in this process is just defining your goals. It sounds pretty straightforward, and it really is. So the first question we ask is like, why do we want this element to be an interactive? And sometimes it's as simple as we just want this thing to spin because it's cool, and like that's okay. Other times you need to move something in a certain way to understand like an exact complex idea or concept, and that's also okay. It's just, it helps to have a direction, an intent, just any idea, however simple it is, to drive that interactive forward. So the second thing we look at is how does it fit in with the overall experience? Where does it sit on the floor plan? Where is it, in the overall layout of the exhibit? How does it connect to all the content around it? How does it supplement or distract? There's a lot of questions to look at where you're putting these interactives in the show. And then lastly, what are the takeaways from each action or movement? Like, what's the point of it? What are you spinning? What is the audience or client supposed to take away, see, and understand? So we look at interactives in the starting process with these three basic steps just to make sure we've got a good platform for moving forward. So keep it simple. More complexity does not guarantee more of an audience takeaway. It's really easy to be like, we want lights, we want it to spin 3 different ways, and we want 6 different colors. But the audience is going to be like, it's pretty cool, like I like these colors, but I don't know what I'm supposed to be learning from this. So it's always helpful to keep the message directed at like one topic, one concept, and try to minimize the amount of complexity and, I don't know, I guess difficulty of engaging with it. So again, user-friendly elements, they encourage deeper exploration. They're easier for a much broader audience to understand, to play with. And then lastly, just fewer complex components make them last longer. There's less to fix. The more complex it is, the more likely that you had to make custom-made pieces, and it could take months to replace those as opposed to a day or two if you're ordering from McMaster-Carr or something like that. And then safety first. Obviously, interactives are largely moving parts. They're typically small, but it's still pretty easy to get pinched, to get squished, to hurt, especially small fingers. So you want to be really careful about where you're placing this, looking at the whole environment where it's being surrounded to make sure that you're not making like, an obstacle course or a space where you're blocking up the audience in the exhibit. So it's always good just to remember that there are safety aspects to interactives that you need to be aware of.
User-centered design. The Smithsonian Institution's User Expert Advisory Group is a collaboration between Access Smithsonian and the Institute for Human-Centered Design. User experts are people with disabilities who have developed expertise by means of their lived experience in dealing with challenges of the environment due to a physical, sensory, or cognitive functional limitation. Oops. Sorry. Oh, hold on. Yeah, sorry. I'm trying to scroll through the notes. User experts review the usability and accessibility of physical environments, museum exhibitions, public programs, technologies, and services at Smithsonian Institution museums. In addition, user experts provide training or inclusivity and accessibility to Smithsonian staff, interns, and volunteers. Accessibility. Consider different levels of interactivity. Some visitors may want to simply observe the mechanics, while others may want to actively manipulate them. Offer options for both. Clearly label and provide signage for the interactive. This includes explaining its purpose, any safety guidelines, and the learning outcomes. We go after the National Park Service guidelines. The National Park Service has a published standard guide for exhibit planning and design and fabrication specifications. We try our best to follow these guidelines when creating an interactive. They emphasize safety, accessibility, and durability. They stress the need for a clear interpretive purpose, simple designs, and user-friendly experiences. The guidelines also recommend using tactile elements, ensuring easy maintenance, and providing clear visitor instructions. Compliance with accessibility standards, careful environmental consideration, and comprehensive life cycle cost assessments are things that we aim for when designing our interactives. And here are some of the guidelines they have, like, for instance, using less than 5 pounds of force to operate. That's very important, and 5 pounds is a lot less than you think it is. We actually have a measuring device to test that with, so that we know we're under that guideline.
It's pretty shocking, like how easily you can make a lever, and then it takes like 25 pounds of force to move, and you're like,
yeah, and you have to start
what
over.
did we just do?
Other guidelines are like being able to activate it with a closed fist, no tight grasping or twisting of your wrist, and all the parts to operate the interactive should be within reach without having to move your body.
All right, so the first step in our process, once we get into the actual production of this, is prototyping. So prototyping, once it gets to our phase, can look a lot of different ways. Oftentimes it's buying raw materials and spending the hours to produce a physical piece that the client, the audience can look at and decide, you know, what works, what doesn't work about this. But it's also like, it includes mock-ups. It could be something as simple as a piece of paper and you're out there in your museum with the audience, like engaging and testing and like, does it make sense to connect this icon and this icon? Simple stuff like that. So there's a lot of really easy ways and simple ways and cost-effective ways to initiate that mock-up and prototyping phase without having to spend a ton of money with, you know, the actual materials and the hours spent in that. So one of the things we do here a lot is digital prototyping. So we use a lot of CAD software, things like Fusion, Inventor, Rhino, and we can really build the elements on screen using real components drawn from either other models online or resources that we've developed and built. And you can develop renders out of these. You can make like realistic videos to see exactly how things twist, how they move. And this is a great first step with, again, not spending the money in building something and seeing, does this actually work at like a basic mechanical level?
And this photo here shows actually the drum over there in that corner, all the components inside that drum, how it works. It was all 3D modeled prior to building it.
And also after this, for those who haven't gotten to play with any of this, we're going to do a little Q&A and get to touch all that stuff. So.
Modularity. Using off-the-shelf parts cuts costs and speeds up production. They offer reliable quality, easy replacement, and compliance with industry standards, fostering flexibility and innovation in interactive design. Component and hardware models can be downloaded from vendors like McMaster-Carr or IGUS and placed into Exhibitry to create interactives. Using off-the-shelf industrial components saves time creating custom components and simplifies maintenance.
So like this clutch mechanism is similar to what we used in this thing. And it's really cool. Like you said, you can literally just like download a 3D model and drop it into your software, whether it's Inventor, Rhino, Fusion, whatever it is, to open that, and it'll exist in a 3D digital format with your components. So it's a really useful way to use like off-the-shelf parts.
Yeah, and this clutch is something we use a lot for
spinners.
You don't want people taking this spinner and whipping it around or trying to take a ride on it or something like that. So you can tune in the basically acts like a brake so that people don't go and vandalize it, basically. So yeah, this video shows a rock interactive. It was just basically turning 2 rocks around we did for DIA. And here shows an example of the durability. Mechanical interactives should be built to withstand heavy use. You want to choose high quality materials and construction techniques to ensure longevity. Though initially often more expensive, it often proves to be more cost effective over time. Frequent repairs or replacements due to wear and tear can be costly and disruptive to the museum's operations. And as you can see there at where it ends in the video, we have like soft stops and hard stops. You want to keep in mind that people are often going to come up and try to rip this thing off the table. So keep that in mind. Bearings and bushing on moving joints. You want to use high quality components, steel, aluminum, stainless steel often, and high wear plastics like UHMW, Delrin, acetal, or nylon.
And I will say about this interactive literally did this, and it was a lot of mechanics for like a very simple movement. It was super cool to see, and it was amazing how it got engineered, but that's like a super complex solution to turning two little rocks around.
Yeah, and the return, you see we use a door return. That mechanism pushing back is what you see at the top of a door in a building. And that was because the interactive needed a reset. Often if you can design something without a reset, it drastically reduces the complexity. Planning for the future. So developing a maintenance plan for interactives is crucial to ensure their longevity and sustained functionality. A comprehensive plan should include regular inspection schedules, routine cleaning procedures, and scheduled maintenance tasks. It's essential to document all maintenance activities and keep a record of any repairs or replacements made. This helps in tracking the interactive's performance over time and identifying any recurring issues that may need special attention. Using easily replaceable components, where is it? Sorry, using easily replaceable standardized components minimizes downtime while incorporating access panels and strategic layout ensures convenient servicing without disrupting visitors or nearby exhibits. So now we have some examples of different projects we've done. This one is the prototype for the Panda Interactive, the Panda Maze Interactive, but as you can see there in the photo is the final one. This project was part of a renovation of the Panda House at the National Zoo. This Panda Maze Interactive was to help visitors learn about the struggle wild pandas face in their natural environment. We designed a maze game in which users would spin a disc-shaped maze to guide a panda puck from one mountaintop habitat to another, avoiding dangers such as roads and farmland. The maze was designed with large knobs for easily handling at various heights and large legible icons representing the environment. The game has no reset or end and can be played from any point in the maze, so that drastically reduced the complexity.
All right, so this next project was a SAFE grant-funded project, and these are the Trailblazing Reader Rails. This was at the National Postal Museum in the Postmaster's Suite. So this was a combination of blind and low vision testing and really working with a few different manufacturing methods. So this was 3D printed on our gypsum printer and then infiltrated with epoxy, a glue, basically super glue, to make it hard. So this gives you a nice tactile of a mule train. And then we've also got a saddle that's printed the same way. And then on the other rails, we had direct printed elements that came from Scott's Graphics Shop that were also raised up and dimensional. So we printed the braille, the letters, and the text all with about a 16th inch of dimension.
So this is the Tactile Engine interactive prototype we created for the National Air and Space Museum. This project was one we did with Air and Space for their upcoming, or it was an older now, Nation of Speed exhibit. It is a full-scale tactile model of a Ford Flathead V8 engine with, which powered hot rods and other modified cars. The learning objectives for the project were for visitors to understand how an engine generates speed and learn how you can modify an engine to make it go faster. So that's why we had the different parts you could swap in and out. This prototype was intended for use in facilitated experiences. Our team created a multi-sensory experience with brightly colored and textured movable parts, flashing lights simulating the firing of the spark plugs, audio playing the sounds of the engine, an LED screen displaying the engine's RPMs. And all these elements were controlled by an Arduino microcontroller, and a lot on the table back there, there's a bunch more Arduino components that are Jeff put together for us. So the video, oh, dang it, sorry. I keep scrolling. All right, go ahead on that one.
All right, so this was another SAFE grant-funded project. This is at the National Portrait Gallery, and this is a Lincoln tactile rail. So again, these were gypsum-printed life masks and hand casts. And these are on display right next to the actual artifacts in the case next to it. So this is an opportunity for the audience to touch them, see, like, get a sense of the scale, the size, texture of what these casts were like.
All right. So that's the end of our examples. Any questions?
Yes. Oh, we got to give you this.
You in the audience here.
Yeah. Do you have any examples of interactives gone wrong? Man, Ian's wheel over at NMAI was a nightmare. Some guy broke his leg or something. It doesn't have to be that dramatic, but just something that what you didn't anticipate.
Man, I don't think we've had anything that dramatic. Typically, we work through these issues in the prototyping phase. I think we've had things that just straight up don't work, and we get 2 weeks in, and it's like, well, that was seriously disappointing and a complete waste of time. Starting over. But I don't know. I mean, you've been here a little bit
We've had
longer.
some components like on this. I've had to replace the puck before, and the acrylic itself got scratched up because that puck is just bouncing around in there and created a trail where you could see where it's basically landed a bunch of times. And so we have a lot of components we've had to replace and maintain, but we kind of anticipated that. To keep costs down, sometimes you can't make it out of the most robust everything.
I'm sure like that hang up, that like pull up interactive at the Spy Museum, I'm sure that's had plenty of incidents, but yeah, we haven't gotten to do anything like that. So.
Yeah, and because we create interactives for different museums that often aren't part of the maintenance, I don't know that we get called out that often, or we don't get to see that often the life cycle over time, what has happened to this interactive, unless it's catastrophic, but I can't think of anything right now.
Right. Yeah.
So you mentioned that it works better if you're using parts that are not like all custom made and everything. How much is kind of custom designed and made generally versus what are you able to source?
So it really depends on the interactive. We can take a look at this drum interactive in a minute, but I'd say like 80% of the components on that were bought out from McMaster, stuff like all thread, nuts, various components, and then the gears that drive that like custom radius, that had to be 3D printed here in-house, developed. So there are certain components, but it probably varies depending on the interactive. We've done custom flip books where it was 100% custom, like milled barrels. It was really slick, cool looking. And then other flip books where it's like U-bolts that you buy from McMaster and buy out printed, pre-printed like flip pages. So it really varies, but I'd say we try and get like 75% of the parts off the shelf just to simplify it. Yeah.
Yeah, it really helps for maintenance and swapping parts out. You can buy them ahead of time and give them to the client. They can keep them in the same cabinet even, as you anticipate this bearing is going to wear out a lot. Every 6 months, swap it out, that kind of thing.
Yeah, and like if it is a custom piece, we generally try to make a few extras to give to the client to be like, it's going to take us 3 months to make this, or you can have a few right now, and as things go wrong, you'll be able to replace them. So, yeah.
Hi, from modeling in 3D to prototyping to creation, how long more or less do you guys budget the turnaround on the design? Because sometimes you might model something, it seems to work, then you go to build it, too expensive, or that's not working too well, what parts can we source for that, let's go back, let's redesign this. So what does your timeline and your turnaround time look like to include all that?
Those multiple revisions. So typically, if we, I don't know, you want to take the first one?
So turnaround time, so for instance, on the drum interactive right now, so like that is a first article and the final. So like sometimes we won't have a prototype phase, or the prototype phase will be part of what's the final piece. So we can cut down on the time in that way. But
I will say that in general, like in the cost estimating and budgeting process, as you begin a project, we'll typically say we'll do 1 round of prototyping, 2 rounds of prototyping, and then in the contract we'll put what that entails. So maybe it's developing 1 first article, but if mechanically like it just doesn't function the way we all expect it to, then you start it over. If it does function, but like somebody doesn't like the color or something, that can be kind of dealt with and navigated. But we try and decide that up front before the prototyping has even started, so that the client and we know, like we're all on the same page, we have the same expectations that there's going to be 1 revision, 2 revisions to those, and we have kind of a set calendar timeline for that. Yeah. There's definitely things that can go wrong, and like time gets, if something's out of stock or it just takes 2 weeks longer to fix something, it happens, but we try and plan for it as much as we can.
Hi, the prototype you have there, the spindle thing, was that designed for the pandas to use or humans? Oh, humans.
it's-
Okay,
it's
so
for
how
humans.
does it work with the pen? I mean,
So there's a little puck in there. You can see it rolling around. And this represents the different mountaintops that they're on, their habitats. And as you spin it around, you kind of guide the panda through the maze. And
Oh.
you hit farmland or other obstacles.
I
And
see.
there's really no way to
Ah.
avoid it, which is kind of like in real life.
I thought, I was thinking the pandas were conditioned somehow to use
no.
this. Okay, I got it. Thanks.
That would be way cooler.
Yeah.
All right, anybody else? If we have no more questions, we can take a look at what's on the tables and play with it, ask more. All right, thank you.
Thank you.